And this over this would be 1, and that over that would be, well, that over that, and that's exactly this. Yeah, I'm just showing you there's another way you could have done this. I mean, it's not obvious.
Only when the powers are equal, right?
Yeah, we have to have a lot of things work out right for us, but seeing that the 4x squareds were the same, the first thing I was thinking was like, wow, if this was minus 4x plus 3, then I'd be happy. But, so I make it happen. Okay, whatever. We're all at the same spot. Doesn't matter. Here we go. So now we want to do the integral of 1 plus x minus 1 over 4x squared minus 4x plus 3 dx. We've reached a critical junction. Everyone can deal with the integral of 1, right? So that's not the issue. It's this second integral here.
Pull out that 4, make the constant.
So what are you doing? You're saying pull out the 4, but what are you? You're going to complete the square. Okay, so why are you going to complete the square? I'm just.
So we can have different terms for
Partial fractions.
Decomposition.
Okay, so what do y'all think? What do we have there? What is this integral? It's a what over what? Linear over quadratic, right? The big question right now you should be asking yourself is whether or not that quadratic is irreducible or not. In other words, can you factor? Does the denominator factor? If the denominator factors, we're going to go partial fractions. If the denominator does not factor, we're going to do what we did the last problem. We're going to make a substitution, and we're going to massage the numerator into what we want it to be. We're going to make it work. But there are two distinct approaches that we have to decide which one we're going to take. So look at the denominator. Does it factor?
No, I don't think so. Because I think you get 2x minus 3 and then 2x plus 1.
So it's irreducible?
If I did it right.
Do you understand what I'm saying? If we're working on just this, if this is the universe that we live in right here, then if it breaks into factors, there should be two distinct linear factors, most likely. And then we can do partial fractions. But if it doesn't break up, then we need to do that u sub thing, that kind of tricky thing. Now, sometimes students will tell me, well, look, if we can't factor this, it's irreducible. I agree. But then they'll say, in partial fraction decomposition, like in the previous problem, didn't we have an x squared minus 4 on the bottom, and it was irreducible? And so what we said is, okay, when we do our partial fractions, didn't we do like bx plus c over that? So students might, sometimes students will say, hey, look, I can just do that to this. Yeah, see, the thing is, we already have a linear over a quadratic, right? We already have a linear over a quadratic. So using partial fractions would just give us a linear over a quadratic, which is exactly what we already have. So you're wasting time to get yourself to somewhere you're already there. Does that make sense? So this means we do one way, partial fractions. If we can't break it up, then we have to do the other way. So I've heard people say it's not factorable. Is it not factorable? No. Do you all agree it's not factorable? Can we move on then? Okay, so what do we need to do?
Make up our big thing.
Make it happen, right? Make it happen. So to make it happen, we're going to look at a u substitution of 4x squared minus 4x plus 3. The derivative of that will need to be 8x minus 4, right? dx. So that's what I want. I'm working on this. Can I erase the 1 and we'll just remember we have an answer, we have an x out here at the very end? Okay. So what I really need right now is for that numerator to be 8x minus 4. So I introduced an 8 on the top and bottom, right? The 8 I'm going to pass through, and I'll leave the 1/8 out here. So there's your 8, there's your 8, there's your 8. Now in this one, I need it to be minus 4 also, right? So I could come in here and do like minus 4 plus 4.
Didn't you do a use of?
I haven't done it yet.
Oh, I'm sorry.
Minus 4 plus 4, but then I already had minus 8 up there. All over 4x squared minus 4x plus 3 dx. And I'm going to split it right there. Right? Because the 8x minus 4 on the top, that's going to match up my u substitution perfectly. Problem just doesn't even, oh, well, I was like, it doesn't seem like it belongs here, but we did have to do long division first, didn't we? But otherwise, it's not partial fractions. I think we're going to stop here. So let's just look at what we've got here. I did these two over that with the 1/8 out front, right? And then here it was 4 minus 8, that's negative 4, and I brought the negative 4 out, and that made it negative 1/2, and I got the 1 over that, right? This one's just a basic U sub. U is that, D is on top, or half, natural log. Right? 1 over U, so natural log of U. On this one, what do we do?
Pull the 8 out, so it'd be 8 natural log of, what's it, 8?
This one?
Sorry, man.
How do we deal with that one?
Complete a split.
Complete the square. Because you have a constant and an irreducible on the bottom. This was like your quiz today. This was like your quiz today. Now I believe, if I'm not mistaken, when I've made these notes, if I'm not mistaken, I probably am. No, if I'm not mistaken. This integral, we did class. When I was showing you, oh, what, no, shoot, that's not it. Hold on. I thought I did it. Damn it. I guess it was. No, but I did not 1 over this. Oh, well. Nah, it's life. But what I did do in class last time was I did do a linear over irreducible quadratic. So I have already gone through this whole procedure before, and where we did have to complete the square there. So you think you can handle? Well, it's time for homework for you. Yes? It's in our note, yeah. Okay. This exact, with the 1 over it? Yeah, because we do get it to that. When I did this problem right here, when I did that, we eventually get to this. Yeah.
That almost looks like what you did with this.
Okay, so now it's time for you to do your homework for this, right? I think we need a little mental break. I'm going to see if I can find this thing. See if this comes up. Y'all can start acting on it. No, that's not it.
It's because it is 1 over 8.
Yeah, the 1 over 8 still follows the mean.
Oh,
So you take that.
Because he just
That's it?
The one where you do have 30-minute periods, they only do what's called
Okay, so look, I can't find this website.
the problem that happened was that we did all the way
Another time.
up to count 3. But the reason why they were doing that is because they were hiring from, they were actually hiring who were
All right, how many of you have a Texas Instrument? How many of you do not have a Texas Instrument? Do not have a Texas Instrument graphing calculator? Do not. Okay. Do you have a graphing calculator, just not a TI? Do you just have a scientific calculator? Okay. So there's 2 people, that's it? Everybody else has a TI? The scientific, okay. So I'll ask for everybody next class to bring their TI graphing calculator with them. If you do not own one, I'm not saying go buy one. What I'm going to do is I'm going to show everyone how to use their calculator to solve a system of equations. All right, on their calculator, just to make sure as you move forward with whatever you're doing in your life mathematically, you have the ability to do it. All right. Okay, so bring that next class. Have a good weekend, right? Enjoy.
Or rather, until you bring it back.
What?